On State Line, the Bracks government refuses an appeal from Racing Victoria to ban betting exchanges.
Racing Victoria have drawn attention to the flaws in the legislation, so you can only conclude this is what was meant to happen, and the Premier has deceived everybody.
And first light, Victoria's Synchrotron passes another milestone. Hello, welcome to State Line. I'm Ben Knight. Tonight, State Line reveals... Well, as a scientific endeavour, it ranks with the Parkes radio telescopes and the Lucas Heights nuclear reactor. And if the experts are to be believed, Victoria's $200 million synchrotron's potential as a sort of giant microscope is going to ensure that scientific research in this country keeps pace with the rest of the world. Well, now, after 3 years of meticulous planning, design and construction, the synchrotron team has just passed a major milestone, a successful test which proves the machine works. Well, achieving that milestone has relied on input from experts around the world. But the team that put the theory into practice is largely homegrown. Matthew Stanley reports.
Synchrotrons can do in seconds work that would take years in a laboratory. But the wheels of government turn much more slowly. And it's been nearly 2 decades since the campaign to build one in Australia first began. Having finally found a willing investor in the Victorian government, it's taken a team of more than 90 different contractors to design and build. But having finally assembled the massive machine, the job of making it work fell to a small team of physicists.
We've been working at it for over 3 years now, calculating the fine points of this machine. So we knew how it should work, but still in the final stages, you always wonder whether you got everything just right.
To avoid exposing others in the event of a potentially dangerous radiation leak, they worked at night, checking and rechecking the various systems, tweaking, tuning, crunching the numbers. They'd been close before, but were nearing the end of another long night without success when yet another test suddenly grabbed their attention. It was a champagne moment, known in the business as first flight, the first time a beam of super-energised electrons has been kept spinning around a ring of high-powered magnets at almost the speed of light. Sounds simple enough when you say it quickly, but venture inside the thick lead and concrete tunnels that hide more than 400 kilometres of cabling, banks of powerful radio transmitters and a conga line of giant magnets, and you start to get a sense of the synchrotron's scale and complexity.
The acceleration process starts back here at the electron gun, which is just like an old-fashioned TV tube. The electrons are then sent into this linear accelerator, and once they reach this point here, they're already very close to the speed of light. They get focused in the centre here, so that we don't lose the beam, doesn't blow up. The green magnets are there to correct any energy problems we have, and the yellow magnets bend the beam around in a circle, so it comes around 360 degrees.
That's the theory. Making it work in practice is something else altogether. The margin for error is incredibly small, and success depends on almost unimaginable precision. The stream of electrons must be steered around a circular vacuum chamber. If they stray off course by just 1 micron, or 1,000th of a millimetre, the beam becomes unstable. And then there's the timing. The electrons travel around the ring 1.4 million times a second. To keep going, they must hit a powerful electric field at exactly the right moment each time.
That's where the synchrotron comes from. It has to be synchronized, and so the synchronization is down to less than a nanosecond. So that's less than 1 billionth of a second that things have to occur. So we need this timing to be just right so that the beam will actually be captured, accelerated and produce the light.
The first successful test lasted just 10 seconds. But it was enough to prove the machine will do what it's designed for, producing super-concentrated beams of light or radiation, from infrared at one end of the spectrum to what's called hard X-rays at the other. Scientists will be able to use the light to peer into things as small as protein molecules and watch how individual atoms interact. The science isn't new. Japan has 11 synchrotrons, the United States has 7. But building one here represents a huge leap in the research opportunities available to Australian scientists.
It's a wonderful day for Australian science. And I think what one should say is you can do the physics, you can do the design, and you can get a start, but then you need really top-class people to put it all together.
There's a long way to go before the first experiments. The beamlines that funnel the radiation produced by the synchrotron still need to be built, but the benefits are already being felt. The team of accelerator physicists, led by American Greg LeBlanc, are all products of Victorian universities. They're the first crop of what it's hoped will eventually become a much larger pool of talent, putting their skills to work right here in Victoria.
One of the things I was charged with when I got this job was to build up that knowledge base in Australia with Australians, and it's gone extremely well, and the team should feel very, very proud for what we've accomplished.
It's a specialised field, and there's a high degree of cooperation within the international community. Having tapped into that expertise, and now having earned their stripes, our own pool of experts is relishing the chance to keep pushing the boundaries.
We have a very young team, and we're going to grow that team, and in the future we will be making developments in the accelerator physics area, but right now it's just an achievement to prove that we can take the pieces from around the world, put them together, and by ourselves make it work here.
I'm very pleased, I must admit. From 1989 there were months and months, nights and night after night, when all I could think about was in fact getting something like this going, and here it is, we're off and away.
Matthew Stanley with that report. Well, you might think a gangster rapper is the last person here in McDonald, and that brings us to the end of State Line for this week. Thanks for joining us, and Kathy Boland will be back next Friday after the news. Good night.
I got my shoes, I got my suit.